Okay, so what we have here is that question from our high frequency, low stakes quiz. And what this question is dealing with is the ambiguous case of the sine rule. So I just want to kind of walk through what that is and what that means, and hopefully it'll make a lot more sense. So in order to answer this first question, part A, it says find the measure of the angle marked theta. So if I wanted to do that, um, in order to find those measures, I have to use sine rule. And sine rule is sine A over A equals sine B over its opposite side. I'm using this version because I'm trying to find an angle. We use the reciprocal of this if we want to find a side length. So what that means is that sine theta divided by the side opposite, which is 18, is going to be the exact same thing as the sine of 28 degrees divided by 15. Just finishing this little bit of algebra foo that we have to do, I would end up with the sine of theta is the same as 18 times the sine of 28 all over 15. So to find theta, we have to use the inverse sine rule, which is just that inverse ratio. And at that point in time, because I don't recognize 28, it's not one of the angles I know, I've got to go to my calculator. So if I do this, I would do arc sine of 18 sine of 28 divided by 15. I need to make sure I'm in degrees. And I press enter. And my calculator just likes to simplify for me. So if I do that, I end up with 34.2888. So theta is approximately 34.288. What was that? 9. Okay. So we have that angle measure. But here's where the ambiguous case catches us. So when we look on the unit circle, if I quickly try to get myself a circle in here, and then I give myself some lines. When we look at our unit circle, and you've been completing unit circles for me for quite a bit now, and hopefully this should hopefully be somewhat automatic. But when I look at the unit circle and I have an angle here that is theta, well, the coordinates here are cosine theta and sine theta. But the deal is, because of the nature of the unit circle, when I come back across over here, there's another angle right here that has that same, like the cosine theta is going to be negative and the sine theta is going to be the exact same. We've seen that again and again when we do this. So what that's telling us is that these two angles have the exact same sine value. So, and in fact, this is actually theta there, so this measure is 180 minus theta. And what's happening there is the deal is that supplementary angles have equal sine values. And we can see that if we go back to our calculator. If I do the sine of, I'll do control answer, I get that value. But if I do the sine of 180 minus that value, it's the exact same. So because we've used the sine rule and because of the nature of sine, what's actually happening here is I have two possible triangles. The first triangle I'll make in green here is the one with that acute angle on the top. Again, nothing's changed here. This is still 18, this is still 15, this is still 28. But this angle here is that 34.2889. The other triangle that we have is its supplement. And that other triangle, sorry, my diagram's gotten a little crazy on me, but we're still fine. Still has 28 degrees here, but here is that complement. Sorry, supplement. So let's just see what that is real quick. So that's my 145.711. All right, so what has happened is whenever we use the sine rule, we always have to be careful when it's in this situation where I have an angle and then two sides. That right away needs to tell me that we've got problems here. There's a possible second triangle that we're not seeing when we do that. And that second triangle, again, would put me somewhere like this, where theta would also be there. And this 15 is the same, it's just that because that sine, because of this nature of the unit circle and the fact that the sine values are the same, what we end up with is two possible triangles. So my answer for part A are those two values. And then it asks us to find the minimum area of the triangle. Well, in order to do that, we have to have two sides and the angle in between. So the easiest angle in between to find is going to be this angle right here. And I'm going to call this angle phi. Okay? So to find that, well, I know two angles, I just have to find the other. So that's going to be 180 degrees minus 28 plus 34.2889. And that'll give me whatever my phi value is. And again, I'm just going to 180 minus 28 minus, that gives me 117.711. 117.711 degrees. Similarly, in the other triangle, we can do the same thing, and we do 180 minus 28 plus 145.711, and I can find what this version of phi is. Okay, so doing that, 180 minus 28 minus, it was that one, and I get this 6.288 value. Sorry, is 6.28 repeated angles. So now from there, because we've got these two different values of phi, now we can insert them into our area of a triangle. 1/2 a times b times the sine of the angle in between a and b. So 1/2 times 15 times 18 times the sine is 6.28 repeated, or 1/2 times 15 times 18 times the sine of 117.711. If we evaluate those two, we'll figure out which one's the smallest. And just so you're aware, obtuse triangles, always with the same two values, the obtuse one's always going to be the smallest one. And that kind of makes sense, because when sine is close to 0, it is, so sine of an angle that's close to zero is close to zero. And sine of an angle that is close to 90 degrees is 1. So the one that's going to maximize area is going to be here, but the one that's going to be smaller is going to be there. But let's just go ahead and plug and play that. So if I do 1/2 times 18 times 15 times the sine of this 117, I'll get that. And if I do the same thing, but this time I put in that 6.28, I get 14.8. So the minimum triangle, the minimum area of that triangle is going to be that. And again, it all comes back to the ambiguous case, because on the unit circle, sine is the same in quadrant 1 and quadrant 2. So we just have to find the supplement and we're good to go. I hope that's helpful.